10. How we feeling, yeah?
2 more weeks to go.
That's right. That's right. We're out of here. I posted your guys out of class. Exams for next week, so have at them. Have at them. They should be well behaved. One involves using the normal distribution to design airline seats. One involves using binomial distribution to analyze testing for salmonella in chickens. Gotta keep the chickens. Chickens. And the last is something called the central limit theorem, which we're going to get into today. We'll probably finish it on Wednesday, I'm thinking. I don't think we can finish it today. But Wednesday won't go the entire length of the class, I don't think. Just because I hate cramming stuff in up to the very last minute. So, anyway, out of class is ready for it. There is an Excel component to it, so realize that. And yeah, there's that. So today, I want to start by asking you, oh, you have a project, yes, right? Project on Wednesday as well?
Yep.
Which is your last, the false positive, false negative project, essentially, is analyzing those kinds of things. Conditional probability of the sequel, part the second. Yes, and I know it looks terrible. Madeline's got it here in front of her. Those two, the formula/tree diagram on the front, the reason I put that there is to give you a sigh of relief. That's not what we're going to be doing in the project. We don't do that. Like, that's the point, is when I learned this stuff in undergrad and in grad school, again, that's all we did was feed numbers into those formulas. And I never experienced an understanding of what the hell was actually going on. And I didn't even know what a false positive was until years later when I started analyzing spam email and spam blockers. And they use this kind of mathematics to block spam, but it's not done that way. It's done in the way I kind of walked you through in the project. So trust me, the formula's not there to scare you. It's just there to go like, oh, thank God. One more formula we won't use in this class. Good. So, all right. So first things first. Because we need the normal distribution to understand the central limit theorem, which is the last thing in the class, yay, and the sun came out as if to be joyful with us. Any questions on the normal distribution? With a previous apology, I didn't get a chance to make the videos for that homework section yet. I apologize. Sorry, Patrick. I didn't get the chance. I'm gonna do it this week, I promise. Sorry. Yeah, Patrick noticed. You may have noticed that. I know, and it's one of those. The weekend evaporated. I totally intended to do it, but I had to make the 105 quiz, craps quiz. And the 105 take-home is analyzing craps. Number 1, what it is, the game of craps. Number 2, why you shouldn't play it and expect to win. And number 3, how it ties into life insurance policies. And that took a lot longer than I thought it was going to. I had to make an Excel spreadsheet to simulate craps, which is wicked fun. And I had to teach myself how to think like a Microsoft engineer, which is basically something I never ever want to do again. Like, this is the antithesis of how Google operates. So anyway, apologies. I fully intended on doing those on Sunday, and Sunday evaporated. So, any questions on the normal distribution? Z-scores, conversions, the Bishop Hotel California showers, which was the application that I included on the homework. You may not have seen that yet, if you didn't get a chance to look at it yet. Patrick, go!
Can you go over that one?
Yeah, good. That was gave you a little bit of grief. No problem.
I'm just missing like one step or something.
You probably. It's probably something pretty straightforward. Let's take a look at it. So let's get into slash. No, understandable. Understandable. Let's see. This was something that my wife and I noticed. So here's the problem. We go climbing down at Bishop, California every couple of years. It's a great country down there. It's kind of like Bend. Very like Bend, but they've got the mountains really close. It's Sierra. There's a lot of granite, a lot of good rock to climb on. And anyway, we decided to splurge once and get a hotel in Bishop because we had mats at that point. And I noticed that when I got in the shower, the thing was basically squirting me in the neck because I measured it. 68 inches from the ground. From the tub to the top, 68 inches, which is, for me, about right here. So what I wanted to do is I wanted to analyze how many people they're pissing off by having a shower head at 68 inches. So I defined a couple things in here. I defined the shower head needs to be at least 2 inches higher than the top of your head. So I'm 5'11", you have to be at 6'1" for me to be comfortable. I define that as comfort. You can define that any way you want to. On your out-of-class exams, I define a ½ an inch of space on both sides of your hips as comfortable in an airplane seat. So, and you have to know this. Men's height 70, men's standard deviation plus or minus 3 inches. So that's for fully grown adult American men-ish. I mean, again, it's one of those things I Google. Okay, so Patrick, what gave you grief? Give me one that gave you grief. Or is it just like you started to give me one?
Starting it for some reason.
Okay.
I feel like Brain farted.
Okay, let's take a look at E1 then. Percentage of men that can fit comfortably under the shower head in Bishop, California. All right, that's for starters. All right. So give me a ballpark. Compare it to 50%. That's a nice number. We like using the number, right? 50-50. We like flipping coins. If we had to use a coin to flip, to decide. So here comes a guy walking into the Bishop, and before the person at the desk even sees how tall or how short that person is, they hand him a quarter and say, flip it. If it comes up heads, you'll fit under the shower head. If it comes up tails, you won't. It sounds ridiculous, doesn't it? Mm-hmm. Is that strategy better or worse than putting the shower head at 68 inches? And to answer that question, you have to know this.
It's the quietest this classroom
This
has
is
ever
quietest.
been.
This is the hardest question I've asked you in a long time. Go ahead, be brave, Renee. Yeah, flipping a coin. Think about this. Think about what this looks like. They're bell-shaped. They're normally distributed. Boom. So men's heights are bell-shaped. We knew that already. I'm going to slide this up. We're not going to need this now. Now that we have that information, come back to it. PC, mute. Okay. So we know, this is E1. We know for a fact 70 inches. 70 inches on average. Plus or minus 3. So we know if we go out one standard deviation, that's 3 inches up, 3 inches down. So 73. This is going to be 67. How many guys there? Ish.
95.
Oh, careful, that's only one standard
that's
deviation.
one standard
That's
deviation.
2/3, right? 68,
Right.
2/3-ish. I always say, I'm sorry, Vice, I always say 2/3, because 68 seems so weird. But yeah, 68% is better, actually. If I go out 2, Madeline, then we're at what? There's your 95, so 64. And if we bump out to 3, which we don't have to go any further because that gets a little extravagant. Okay. So what percentage of guys are less than 70 inches? 50, less than 50%. That's why flipping a coin is actually better than their strategy. Because at least with the coin flip, half of them are going to fit under the shower head. The question I have is, what percentage fit under the shower head if the shower head is at 68 inches? Now you got to remember, the shower head's at 68. That means the tallest the guy can be
66.
is 66. We got to take that 2 inches off the top because we're defining that. So in other words, in order for a dude to be comfortable on the shower head, he cannot be any taller than 66 inches, which means he can be right here. Now, can a 67-inch tall guy be comfortable?
No.
70-inch?
No.
64?
Yes.
65?
Yep.
Pretty much all these guys down here are comfortable. They're comfortable, yes? What is that area? That's the question. The question is, isn't it less than 50%?
Yes.
It has to be less. That's why my coin flip example was actually better. If you decide by flipping a coin, half the guys that walk in are going to fit and half the guys aren't. This is less than 50%. My question is how much less? So this is the forwards problem, yes? Given 66, you need to get to the area which is in the question mark. That's what your job is for E1. Yes? Fair enough? Let's do it. Let's do it. We get back to it. Once you see what you have to do, it's fairly straightforward, yes? So, it's a classic forwards problem. We start with raw data point. What do we do next? What's step 2?
Left.
Say that again.
It's the left area.
It's left area, good, but before that, Nick, I love what you're saying, it's 100% correct. What do we got to do first, before we go to the program, which I want to do? What do we got to do with this? We got to standardize it. The problem is, this curve is not in your TIs. This curve is. Correct? You have to turn this into a z-score. These are all in inches, which are units, which is great. That's fantastic. It's a general normal problem. We've got to convert it to this is step 2 on a forwards problem, is convert data down to a z-score. Yes. Now it looks like it's -1 1/3. It looks like it is, but in case you're not doing that kind of conversion in your head, that's why I will give you the formulas on the board, of course. A forwards conversion, for the forwards conversion, you're going to have a data point. I like to call those x. You're going to subtract off the average, which we call mu, and you're going to divide by a standard deviation, which we call little sigma. And that tells you how many standard deviations up or down you are from average. And when you're done, that'll be a z-score. When you're done, that'll be a z-score. So all your job is to feed stuff into this. So you know the data point you're interested in is 66 inches. Excuse me. The average is 70. And the plus or minus is 3. So you got negative 4/3, which is negative 1 1/3. We now have exactly what Nick wants. What Nick wanted was he wanted a value to shade left from. We now have it, yes? Good. And that was step 2. Step 3 is to do the shade left and see what the area comes out to be. Let's do it. Let us do it. Oh, goodness.
Oh, hey, Sean.
Please.
I don't think your camera's on.
You don't.
It's flipped around.
Oh, it's flipped around.
What did I do? I'm sorry.
No, this.
Oh, yes, I did that. Why did I do that? I'm looking at myself. That's awful. There.
No, that's okay.
No,
I
it's
was
not,
thinking
actually.
that it wasn't right.
Myself. It's terrifying. All right. Thank you, Heidi. Thank you for checking, though. And I do apologize, Gesundheit. I have not resolved the YouTube issue with that one video. They re-uploaded it somewhere else. Sans viruses. Although there were no viruses on the original one, so if anybody can't find that one.
Have you noticed that there's a lot more views on your videos now too? Because before, when you had said that about the only one view per video, I had been seeing those videos multiple times, so there should have been several views. So then I went back, and there were all of a sudden several views on a lot.
Several's okay. YouTube is claiming.
Well, not
YouTube is
like
claiming
they're
like thousands and thousands and thousands. I'm like, I
But there
got like
must have
100
been a
students.
glitch or something because there was only one view per video, and I know there was more than that.
What was it? It's a false positive. As I'm trying to explain to them, it's a false. You've tagged it as a virus when there's no virus because your program isn't perfect. It's okay. We like math. All right. Thank you. Thank you. Here we go. Programs done normal. Forwards or backwards?
Forward.
Definitely forwards because you don't know the area. You're looking for the area. That's a forwards problem. We're going left, just like Nick said. This is in the wrong place. Here we go. We're going left. The right bound, negative 4/3. Ba-boom. Here comes the area. That roughly corresponds to what we drew up there. Can't really see it. 9%. 9% of guys are going to fit comfortably. Question E2, is this acceptable?
No.
God, no! Hell no, it's not acceptable. It's ridiculous. 1 in 10 people, 1 in 10 guys are going to fit comfortably under that shower head by that definition. It's ludicrous. It's completely ludicrous. Why would they do that? Why would they do that then?
To save on the cost of building?
That's the only thing I can figure is to save on the cost. Copper is expensive. And I think they use copper pipes for those runs. So if they can lop off a foot times maybe 2 if they're using copper in 2 different places in the bathroom somewhere, or 3 times the number of rooms, times the number of hotels, it becomes real money. But
And the chance that you're not going to come back to the Ramada in Bishop
Because
is
of that.
probably low.
exactly, because I don't go for the hotel shower, I go for the granite. But yeah, exactly, exactly. That's exactly right, Madeline. Yeah. So it's a good gamble for them. That I'm probably not going to not go back there because of that.
And
But I find it interesting that they're inconveniencing 90% of guys.
yeah.
Now, of course, this is my definition of comfortable, yes? I forced that to be 2 inches above the shower head. That's what I called comfortable. What I ended up doing was just flipping it up like this and having a little arc going under my head, which is kind of a fun game. Trying to have the frap over my head. But then again, I'm ADD, so that's the kind of fun stuff that we do to occupy ourselves. But, the other 90% of people with me might not be as, happy about that. But I don't know. It's just fun mathematics. Patrick, make sense?
Yeah, I just.
Dude, absolutely. That's how you get started. Now, speaking of getting started, thank you for that. When you encounter a problem like this, granted you know it's going to be a normal problem because it's in the homework for the normal distribution. So it's like, okay, it's going to be a normal problem. But how are you going to know next week when we're sitting in class together? I think your exam's Wednesday.
Wednesday.
I think, yes? How are you going to know that it's a normal distribution problem on Wednesday when you're sitting here? It's almost a trick question. It's almost a trick question. Read it again. Read it again. It's almost a trick question. Very good. I give an average and a standard deviation, which I will not do.
And you say that the
And I
data
al-
are normally
I
distributed.
also tell you the data is normally distributed. I have to do that. I have to do that. I have to tell you that because the only way you can convert to... Every data set has an average and a standard deviation. You guys know that. You can calculate those things. But in order to feed those down and stick them on that curve, there has to be that curve. And that's why this part has to be there. So when you're thinking about next week's exam, and we're going to keep talking about this today and also on Wednesday, because I don't want you guys to be surprised by what you see on that day. When you're looking for a binomial problem, it won't say normally distributed. You'll see things like a fixed number of trials, a probability given to you in there, like a 0.9 for the girls and the bullets and things like that. But for the normal problems, you'll see something like this, an average and a standard deviation given to you, which FYI, I won't give you for the binomial problems, because you're going to give them to me. I'll ask you what the average is, and I'll give you 5 points for it, because that's kind of the point, is I can ask you for the average, you can figure it out, tell me what it is, and I give you 5 points for it. But that's the big kind of thing you look at and go like, oh, I got it now. That's what kind of gets the ball rolling. Once you guys get the ball rolling, you've got this. You'll have the formulas in front of you, for sure, guaranteed. Gesundheit, Gesundheit, Gesundheit. I'll have the forwards and the backwards formulas on the board for you, happily, don't memorize them. But as Patrick said, very often it's just the getting the ball rolling part. Absolutely, absolutely. So, I also did this estimate the percentage of women in E3. It's basically a replication of E1. I followed Danny's eyes right then. She looked up to look for the average height of a woman, which is not up there. If you look at the answers, I'd tell you, you may have to go Google the average height of a woman. I don't give it to you in E3, but down lower I give it to you. I did the right, 64 inches right there. I told you to estimate it first.
Is that 5'4"?
Was 5'4" on average.
Wow.
Yeah, it's funny the perceptions we have of average heights. Like 70 inches for a guy is, what's that, 5'8"? Mm-hmm. Yeah, right, 62, no, 60 plus, no, it's 5'10".
5'10".
It's 5'10", isn't it? 60 inches is 5 feet. Stupid imperial system. 60 is 5 feet plus 10, so 5'10". And for me, it's like, oh, I think I mean, I'm 5'11" and a half, so I'm like, I'm a smidge above normal, and I'm within a standard deviation, so it's like, yeah. But you're taller, so then 6'4" would seem more odd to more of an outlier data point.
Oh, 5'4".
Mm-hmm. Exactly.
Yeah,
exactly.
I thought it was 5'6". So.
No, it's 4, yeah, 4 above 5 feet. So, but anyway, do you see how E3 is exactly the same as E1 once you know that average? Of course, of course. Now, here is a question I leave you with, Patrick. At which height should the shower head be placed so that 95% of men can fit comfortably? The problem, yes, the problem just shifted, didn't it? It just shifted to a backwards problem. It just shifted to a backwards problem. So in other words, we've got to raise that bad boy up, don't we? I'll get you started on this one. I'll get you started, because I want you to you can totally finish this once you get started on it, but it's definitely a backwards problem. So let's go through this. The first thing we did in this forwards problem was we took 2 inches off. So we keep that in the back of your mind. That's like an extraneous little thing we have to redo. We have to add it on at the end of the next problem. Then we identified the data point, converted the data point to a z-score, and then ran the z-score through to get an area. And then we were done. We've got to do all of that backwards now in this problem. So let's get you started. Okay? So for E4, it's the same curve. It's the same curve. But what you now have to do, let's get 66 out of there, because that won't do, obviously. You've got to find the 95th percentile, don't you? Essentially, if we're going to use language we've already, 95th percentile. Where is that going to be?
Isn't that 76?
Careful. It's actually below 76. Now, I know what you're thinking. You're like, Rule, you just got done saying that 95% of the data is between here and here. And it is, correct? But the trick is that if you make it between here and here, that's like saying that people under 64 inches won't fit. They have to fit, obviously, correct?
Okay.
So we've got to shade all the way. Now we're up to 50%, yes? That's 50. I grabbed the wrong marker. I need a blue one. We've got to shade. There's 50%. This is an additional 34 from our work on Wednesday of last week. So now we're up to 84%. We've got to keep going, and this is the part I don't know exactly. Somewhere in here is a z-score that tracks 95% of the area. Somewhere in there, between 1 and 2. Your job, run stonormal and find it. Once you have stonormal and you found what that z-score is, convert using this guy in reverse to figure out what that is. And then the only thing that's extra for this problem is add 2 inches back onto it. Because that's the height of the 95th percentile guy, but you got to put the shower head 2 inches above that in order to, that's only to this problem, that's backwards to this problem. In general, you found the 95th percentile for guys at that point of the conversion. Fair enough? Good. So that's that. That's that. And these are perfect exam type questions. I got a fun idea for one. I wrote Tower of Terror with my father-in-law, which was enjoyable. Any person that screams more than I do on those rides. I found that screaming holds your stomach in place. You don't want to vomit as much. But, yeah, exactly. But I watched, as I walked on the Tower of Terror, they have like a little height restriction. And there's something tied to age as well. And I thought, like a great exam problem for you guys. We're going to analyze 5-year-olds. I couldn't talk Max into going. He was 5 at the time. He saw it. He's like, I want to do that. And then we got closer. You heard him screaming. He's like, I don't want to do that anymore. And I was like, but you can get on, buddy. You're tall enough. And he's like, what do you mean? And I told him the rules that I had seen. I think it's, you have to be 42 inches or something like that at 5 years old in order to ride the ride or something like that. And I thought to myself, that's a great problem for you guys to crunch through. What percentage of 5-year-olds could ride Tower of Terror? Boom. Because heights, like weights, well, heights are normally distributed. So anyway, came back to Disney with that tacked down in my book. So do that next week. Tower of Terror. Good stuff. Anybody ridden it? Crazy ride, crazy fun. That entire row has ridden it, nobody else. That's the essence of random clumping. Excellent. Great ride, great ride. Cool? Believable? Yes. Apologies for no videos, that'll be fixed shortly. I'm thinking before Wednesday, hopefully today. Hopefully today. I think I have the docket cleared as far as that goes. If anybody comes back during office hours and the door's closed today, it just means I'm making videos. So just knock on the door and I'll just pause it. Cool? Normal distribution. Good, good. So, what I want to do next, turn the lights on first of all, is I want to have one small extension to this. One small extension to this, and it starts with dice. So here's what we're going to do. I need you guys pair off. I think that'd be the easiest thing because there's so many of you. Pair off. Make sure there's no more than 2 in a group. And if we have an odd number, I can pair off with somebody too to play. I got an in-class quiz for us to do as well. Let's not give it to you yet though, because I have something else for you to do first. So pair off. I'm going to hand you guys around some dice that I made. They're custom, and you'll see why they're custom momentarily. Grab a pair. The pairs are different colors, but they're different colors, but not. So like the yellow pair has 2 different shades of yellow. The blue pair has 2 different shades of blue, 2 different shades of red, 2 different shades of orange, and 2 different shades of green. Because in general, they're different. The 2 dice are different. They're not like a normal pair of dice. Each die has, they have no more than 6 dots on any given face, and no fewer than 1. But that's pretty much where the similarities end. So grab, actually I'll just give it to you guys. Yeah, that's what we make sure. Yellow, you guys are grouped down here. Blue, Patrick and Nick, you guys are red. I'll also turn the camera off. The world doesn't need to see this. You guys pair